Camera speeding. This is an interview with Cullen. Marking.
It's good to meet you.
Who are you? What do you do?
So, my name is Cullen, and we have brought, through collaboration with Tier, we built and produced South Africa's first large-scale modular cement 3D printer.
This gets me immensely excited immediately. What do you do? What is the problem that you solve?
Okay, so it was a bunch of us. It was actually 4 engineers, and we were working in our offices, and we were looking at housing. And you know, the job market or the housing market is quite competitive. It's quite difficult to actually get the funds together. And
understatement.
So on. Yeah, I know, it's quite difficult. So we thought, okay, well, we've got these really cool degrees, and why don't we just go out and build something that can give us a house that's a lot cheaper. So that's where we came up with the whole idea of cement 3D printing.
Fantastic.
Yeah.
How's it working out? What phase are you in? What are you looking to do?
Yeah, so it's working out really well. So we've been pretty much under hush-hush for a little bit. We were just going ahead doing the patent applications and filing those applications. So we needed to keep it a little bit under wraps. But now that it's all filed, everything's good. Now we can come to these events and actually show everyone what we've been working on. So at the moment, we've got a printer, and it's running. We're still doing a couple of trials with it. And we are looking to expand this and then actually do full-scale trials in the coming year.
Right. Okay, so let's dig into this a little bit. So building a house, usually we lay foundations. We've got brick by brick, outside walls being double walls, inside walls being
single walls. Yeah.
And then recently, I think one of my favorite ways to build is actually the pouring method, where they kind of pour into these forms. How does it stack up to what we normally experience in the industry? What's the comparisons there?
If you've ever been to a job site, you know it's quite messy. All right, so there's everyone running around laying bricks and all of that lovely stuff. So what our technology allows us to do is go to a job site, keep it very clean. We can then also go ahead and lay the exterior and the interior walls at quite a discount to what you would be doing with a traditional method. So your interior walls, non-load bearing, we can do for about 10% cheaper. And then where the big savings come in is your load bearing walls. And those walls we can do for about 40% cheaper, yeah. So it's quite a significant saving there.
I'm just going to make notes here for when I want to build my house. So it's per square meter, what do you normally budget on?
So it's a little bit difficult. We need to actually look into the particular sand in the area and whatnot. So when it comes to printing on site, we would need to get sand from the local quarries. We don't want to transport sand around. We also need to get the cement from the local suppliers over there. We do some lab tests on them, and then we create a concrete that's specifically designed for that area.
Because I'm assuming it has to have a certain texture, dexterity, just to be able to actually physically print this.
Yeah, we want to get it into the consistency of almost like clay.
Yeah.
Yeah, I know.
So it's a little bit thicker than traditional concrete would be.
It is.
Significantly thicker.
So the workability is something that we did a lot of learning on. So the actual engineering behind it is quite straightforward. But then when it came to pumping the concrete and the concrete mixtures, my word, concrete is a wild animal to deal with. So did a lot of work into that, and we came up with something that's actually working for us right now.
I can only imagine. I did a concrete pour once on a slab for a table that I was building, and I was like, the more concrete, the stronger it's going to be.
Yes.
That was not ideal. And something I've never realized as well, it keeps on curing. It doesn't stop curing. Like, how do you solve problems like cracking, and how does that compare to modern buildings?
Yeah, so we've got some quite nice additives that we can add into the concrete. It's a lot of attention needs to be placed in how the concrete cures. So if we are printing externally, so outside, if we are printing with the side facing the sun, it's going to cure quicker. So that discrepancy between your cure times on the different sides of the house is where we need to pay special attention. So we would want to do some cooling, maybe spraying the concrete as it prints with some water, just to make sure it cures in the amount of time that we've designed.
Yeah, because that's also like a side, what do you call it, a side symptom of possibly developing a new type of concrete or a different texture, is like it cures differently, it acts differently.
Yes. Yeah. So what we like to play around with is curing times. Okay. So as we are laying the concrete, we obviously can't go too high before the bottom layer starts pushing out. So when we slice the house. This is what we like to call it. So we turn it into layers so that the printer can
Like an
actually.
MRI.
There we go. Yeah. So we MRI
I know
the house.
stuff.
When we do that, we take into account the travel time for the concrete, and then we make sure that when we're about 500 mils high, then we've got a consistent layer at the bottom and a consistent hard layer at the bottom that can support the consecutive layers moving upwards.
Right. Okay.
Yeah.
So we've spoken about the economic advantage. What other advantages are you seeing? What sectors can this have massive impact on?
Well, let me ask you: have you ever tried to put in a cabinet in your house?
I have.
Yes, and you know that wall is not 90. Right? It's
There's
always
nothing.
something.
There's nothing. Yeah, that's just hoxie. Like I don't know how to say that in English, but there's nothing that's built square.
No,
Never.
not even.
Are you saying you can do that?
I'm saying we can do that.
I think you're lying. I've heard this from contractors a million times.
Oh, it's machinery, you know. It's machinery.
That makes it better.
So the machine's not lying. Maybe I am. But the machine won't be lying. But Joe, we can do 90 degrees. This sounds like such a weird thing, but we can do 90 degrees proper.
That's immense because carpenters probably hate builders the most.
Yeah, and also the wavy walls. That's all.
Yeah.
We're all getting rid of that. We can also do some very innovative things. So convective cooling, which is quite cool. Since we can do shapes, no additional cost, we can include flutes into the walls and a particular geometric shape.
Cavities.
That allows cavities, similar to cavities, but we want the geometry to be almost like a flute. And then it funnels, so as the exterior wall heats up, pulls the air through, cools the interior walls, and then during winter you can stuff the bottom of the flutes.
Of course.
As an additional insulation. So we can get really creative JoJo tanks. We can just print them into your house. So when we print the house, we just print the JoJo tank as part of it.
We recently had this conversation. We've got a client who she's now South African based, and she's a link between America and a local NPO. And she comes from a very cold part of America. I can't remember exactly where, but she said she's never experienced winters like she does in South Africa because our houses aren't built for winters. They're built for summers, and it's not insulated in the way like. So something like this could be immensely useful if we start building in smart designs.
Yes.
If I look at how buildings are built today, it goes up like this, but there's no real thought put into like climate control and temperature control, especially in lower cost housing. So this can be an immense contribution. This is awesome and quite frankly a little bit mind-blowing. Of course, you're a bunch of engineers together. It seems like there's a lot of specialities, technicalities coming together. What is the foundational team made up of?
Okay, so we've got our electrical engineers.
Okay.
So they're known as the Sparkies. They like to deal with the wires. Then we've got the mechanical engineers, and they like to deal with physical things.
Is it a combination of both?
It's a combination of the two, and we throw in a bit of software there as well.
Right.
So a bit of computer science. So
okay, this is way more interesting.
yeah, it is a very lack degree.
Okay.
A lot of other engineering disciplines will always say that what is it? Jack of all trades.
Yeah, master of none. Yeah.
But still better than a master of one.
Yeah.
That's the full saying. They like to cut it off at the end there. So that's what we like to think. We like to think we're multidisciplinary. We also see the different strengths of different engineering disciplines.
Absolutely.
So we call on their expertise when it is needed.
That's fantastic. And then I like to say within entrepreneurship and successful businesses, we often find the intersect of industries and expertise. How did you end up in entrepreneurship? Is this entrepreneurship? Is this full-on startup?
Yeah, I think it is an entrepreneurship. We've come up with an idea and now we're pursuing it. We're trying to take it to market. We saw the need for it, to be honest, and we all wanted to be more creative than what a normal 9-to-5 job would allow us to be.
Yeah.
So we were very blessed to be in an environment where it afforded us to go out and actually adventure into this.
Yeah.
We've got other jobs that actually keep us busy, pay for the 2-minute noodles I like to joke around with, while we actually do our main passion, which is this.
So you're still looking to find product market fit, you're still looking to put this into a commercial business, or are you there yet?
So what we are looking into is to do some more collaborations with key stakeholders that we would like to identify. So SMMEs are one of the ideas that we would like to target, where we could provide this technology to them. And all they would need to do is take the technology, deploy it in the field, and then make sure that it runs correctly. And then also further on collaborations with universities and whatnot to do research, bring the research home, bring it to South Africa. We've got some of the best cement technologists, concrete technologists, I think that's what they call them, around. So let's collaborate, let's bring it into South Africa, let's make 3D printing something that South Africa can push into the rest of the African continent versus bringing in from the Europeans and the Americans.
I can think of one specific application in South Africa that's obviously massive. It's low-cost housing and RDP housing. Have you explored public partnerships, opportunities with government?
We are pursuing that. So we will be looking very forward to that. And Tia is going to encourage us to go through and look through different, explore different areas with different governments and whatnot to see where we can help out.
Awesome, fantastic. I mean, we can carry on talking for ages. Actually, the question I want to ask is size.
Yes.
What is the biggest you can build? What can you build? What can you not build? What is the limitations of this technology?
So our main ethos was to make it modular, so that we can actually add on bits as we see fit. So our main limiting factor is just the length of the beams that we are using. So our X direction, we can go 12 meters, and then our Y direction is effectively limitless, but I like to say about 50 meters would be pretty cool. We would have about 4 towers that just support the gantry system moving 50 meters across.
Okay.
But because it's all software based, we can always print a section and then move the printer, and then we can account for those, let's say, limitations that we might have, but not really limitations, just yeah.
Okay, and height?
Heights, we can go 2 stories. Right now, we are targeting 2 stories. We don't want to go anything more than that. We'd like to just bite off enough that we could chew.
Yeah, I read that's a good way of looking at it. So the big question then is, like, anyone who's dealt with home renovations and contractors specifically know that when they say they'll be done in June 24, they will possibly be done in
not then
26.
Yes,
So,
yes.
are you efficient in timing? Like, how does that efficiency play in?
Yeah, so one of the ideas that we were exploring is how we would interact directly with a customer. So if you need to have a garage built, for instance, right, you would go ahead and you would have the foundation dug, and then you would call us in. Once that is done, well, actually, while you're busy digging the foundation, you can get us to set up.
So you don't do plans, nothing. You come in and you build on the plans.
Yeah, so we would need to see the plans and whatnot. We need to go through a bit of a process before we actually do the printing. But once we're on site, we're aiming to do about 65 squares in a day. So we would like to print that in 1 day. So foundation to roof in a day. So I mean, that's pretty much a garage, I think. So that's what we're targeting. And it's no fuss, no mess. 4 or 5 engineers on site. And we just get the truck in, pump the concrete into the printer, lays it down for you, and we say thank you very much, shake your hand, pack up and leave. And then you've got your structure.
I like this.
Yeah,
I like this a lot.
Lots of fun.
Plus, you're engineers with personality, which is very scarce.
Oh, yeah, maybe. No. Listen, I've gone past my laughing quota for the year, you know. So, yeah, no, might as well just go out swinging.
This is fantastic, Cullen. Is there anything you want to add to this? I think we've covered quite a lot, but yeah.
Well, I would like to add, if anyone wants to collaborate with us, partnership with us, we're all open for discussions. We would like to see where we could find a good market fit. Maybe there's some ideas that we haven't come up with yet. I mean, we're only human. So some more concrete ideas that anyone might want to collaborate with us on, then we are
more concrete ideas.
More concrete ideas.
Pun intended. Right, awesome.
Good thing you caught that. Yeah. Cheers.
That's awesome. Like, I'm just actually flabbergasted about this.